All right, so this is on page 9 in your green notes packet. I need you to have your calculator and pencil, maybe some highlighters ready. What we're going to do in this part of the unit is talk about the right triangle. And specifically, here's the right triangle, right? Which one is the hypotenuse in this triangle? Well, if I look at this, AB is the hypotenuse. Okay? BC is the leg, and AC is also the leg. And which one is the altitude? Well, the altitude is right here, the height. Altitude is another word for height. This is the height. But if I look at this right triangle, which other side could be the altitude? It could also be side AC, because it makes a right angle here. And it could also be BC right here. So anytime you have a right triangle, there's 3 possible altitudes. Right down the middle, because it makes a right angle here. One of the legs or the other leg. Basically, if I look at the triangle like this, if I rotate it, that would be the altitude and that would be the base. Okay, depending on how you look at it. So now, how many right triangles do we see? Well, if I draw the altitude, there's one right triangle here. That's the smaller one. And then, here's the smaller one right here. So technically, we have one, like the big one, that's ABC. Let me redraw it like this. C is right here, A is at the top, and B is right here. So that's the big original triangle. Then if I draw this medium blue triangle, it's D is the right angle right here, DC is the shorter leg, and DA is the longer leg. And then the tiny one is this green one, and I'm kind of repositioning it so that this is D, this is B, and this is C. Maybe it's not that much smaller, but you guys get the idea. So what I want to show you is what ended up happening to our altitude that we drew right at the start of the, highlighting all of this. So DC right here is actually, it's not even in the original one, it's not even part of it, because it's this segment right here. Okay, if I drew DC. What happened to DC in this middle triangle? It ends up being right here. So it's like the short leg of the medium triangle. And then what happened to DC in this small green triangle that I have? It's right here. So that entire segment ends up being a different part. It's the altitude in the big triangle, but then it's the one of the legs, the shorter leg in the middle one, and it ends up being the longer leg in the small triangle. Okay? So since we've done the similar triangles unit, we can kind of write proportions that compare the altitude, the shorter leg, and the longer leg. However, there's a different way that I want you guys to remember it. And there are 2 proportions that we're going to write that involve the altitude and the legs in this triangle. So here's the idea. What we're going to be able to do is, let's say I'll give you this segment right here is 5, and let's say that this part of it is 7, we will be able to find the altitude. That's the whole point of today. Okay? Or, Pythagorean theorem, it's actually very limiting. It's only one thing. Like if you're given this leg and this leg, you can find the hypotenuse. What you'll be able to do is, if you know that this is 5, and if you know that this is 7, you will be able to find this leg. So really, with only one side length, we are able to find side AC, and we will be able to find side BC without using the Pythagorean theorem. So we're adding another formula to solving right triangles. Okay, so I know that that was kind of a lengthy intro, but that's where everything comes from. So here's the first theorem. I'll give you guys a second to read this sentence to yourself. Now this word geometric mean stands for the fact that it's going to be a proportion. So again, the altitude is drawn to the hypotenuse. So that's h. And it separates the hypotenuse into two segments. So this time around, I would like you to take your yellow highlighter. AD is going to be the yellow one. And let's do hot pink for DB right here. And the proportion, what I'm finding is that you guys remember it best if we use the words. So, the altitude proportion looks like this. 1 part of hypotenuse over the altitude is equal to the altitude over the other part. Some people actually really like using the letters that we have on this picture. So it would be x over h is equal to h over y. And I like to think of it as like it makes an T right here. So this part of the hypotenuse over the altitude, back through here, altitude over the other part. So like this would be my yellow part. The altitude gets used twice. That's why it's called the geometric mean, because we're multiplying it by itself. And then here's the other part. So eventually I'm going to make you rewrite this and maybe even do a picture on your yellow packet where we have all of the facts, because this is something that you'll have to remember. 1 part of hypotenuse over altitude, altitude over the other part. Okay? Are we ready to move on to the leg theorem? Okay. Take your time, guys. Take your time. Make sure your picture matches mine. If I refer to yellow, pink, orange, it does help. All right, here is the leg proportion. Set up your proportion bars. So again, the altitude drawn to the hypotenuse of a right triangle separates the hypotenuse into two segments, here and here. So let's keep the same color scheme so that we have this as our yellow and this as our pink. The altitude is still this one, but it's not used in this problem actually. In this proportion, you don't have to use this. You only use the altitude because it splits it into this is one part of the hypotenuse, this is the other part. The length of a leg of a triangle is the geometric mean between the length of the hypotenuse and the segment of the hypotenuse adjacent to that leg. What does that mean? Which leg is adjacent to x? Which one is x touching? Leg A or leg B? This is the entire hypotenuse of the whole triangle. This is one of its legs. This is the other leg. So if I'm talking about this part of the hypotenuse, the part that's adjacent, or I like to call it connected part, because it's touching it at vertex A. So if you're looking at this part, connected leg would be right here, and which would be connected to Y, right here. Here is the proportion for the leg theorem. You're going to take the whole hypotenuse and you're going to divide it by the length of the leg, and then the leg over the connected part. So we haven't highlighted the hypotenuse. So you guys pick what color should we make the hypotenuse. What haven't we used? Either green or blue?
Brown.
We don't have brown. No, green. Let's go with green. Let's go with green. So the entire hypotenuse right here is C. So you're using this right here. We're using all of the hypotenuse, which is C. That's going to go right here. Now it all depends on which leg you're going to be solving for. Let's say we're doing leg B. So that's going to go right here and right here with the connected part. If I was trying to find leg A, that would change the problem a little bit because I would be using leg A and I'd be using this part right here. All right, so I know I just did a lot of explaining. Let's see it in action and I think you're going to understand what's really happening. So the connected part depends on which leg you're trying to find, whether it's B, so it'd be this part. If it's A, it would be this part. Let's see this in action and it's going to make sense what we actually do with this. Go to the next page, please. At the top, let's write the proportions again. The more times you write it, the better you're going to be at remembering it. So the altitude proportion is part of hypotenuse, so I'm abbreviating, over the altitude, altitude over the other part. And eventually you'll do so many of these proportions that you'll get the hang of it. Part of hypotenuse over the altitude, ladies, altitude over the other part. Let's write the leg proportion as well. It's the whole hypotenuse over the leg over the connected part. So each of these pictures will have all of the pieces and parts on the diagram, and you have to decide which one it's going to be. So over here, I would know that this is the altitude proportion, which is this, because none of the legs of the, and when we say legs, it means for the entire right triangle, neither this bottom part or this, that's not labeled. So this is the one where we take part of the hypotenuse over the altitude, which is x, and set it equal to the altitude, x again, over what's the other part. So when I say it makes like a T shape, this is what I mean. You start with 3x, x over 6. Let's cross multiply. X times x is x squared. 3 times 6 is 18. Take the square root of both sides. What's the biggest perfect square you can think of for 18? It's 9 times 2. Square root of 9 is 3. So the answer would be 3 root 2. Again, for this section, there's not going to be any decimals for the most part. Everything has to be simplified. Why don't you guys take a look at this one? And this is also altitude. See if you can set up your proportion. Think of the T shape. And it really is okay if you started either with 9 or x. So it'd be one part of the hypotenuse, which is 9, over the altitude, which is 5, back through here, so it's 5 over x. If you started with this, it'd be x over 5, and then 5 over 9. Either way you do it, you get the same answer, because you're multiplying the same numbers. 9 times x equals 25. Divide by 9. And we get 25 over 9. Next one. This is still the altitude proportion. Take a look at this. I have one part of the hypotenuse as 4. The entire hypotenuse is x. So what's this other part going to be? No, the 10 is just the altitude. I know what you're thinking, but the 10, x minus 4. Minus 4. So it's the entire length minus 4. Let's say that I said the hypotenuse is 12, for example. You guys would know to do 12 minus 4 would be 8. So the entire length minus the part we're given. So part of hypotenuse over altitude, altitude over the other part. 4 over 10 equals 10 over x minus 4. Let's cross multiply. So we have to distribute 4 and then x minus 4 equals 100. Distribute the 4. Add 16 and divide by 4. And what is x equal to? 29. Because you add 16 and divide by 4. All right, the next 3 examples are going to be about the leg proportion. Because if you can see, look, the altitude is not even like labeled. So right away, that's a giveaway. I have this leg, I have the hypotenuse. I have this leg labeled, and I have this hypotenuse. Hypotenuse and leg. All right? So the entire hypotenuse over the leg, leg over the connected part. So over here, what's the entire hypotenuse equal to? 9 over the leg, which is x, equals the leg again, which is x, over what's the connected part to it? Just 6. So this is the 2 parts of the hypotenuse, and the connected one is the one that it's touching right here. Cross multiply and solve for x. Simplify, find the biggest perfect square. Did you get 3 root 6? Yes. Yep, all right. Please try to set up this one right here. It's the same proportion. All right, before you try solving it, please check your answers with mine. So the entire hypotenuse is 7, the leg is x, x over 2, because that's the connected part right here. Cross multiply, x squared equals 14, and there's no perfect squares that go into 14, so the answer is square root of 14. All right, let's try one more. This part right here, we've got the leg is 10, the connected part is x. Eleni, how do we figure out this little part right here? If this part is x, what would we do right here? It is 14 minus x, the entire length of the hypotenuse minus the part that's labeled. So the proportion is the entire hypotenuse, 14, over the leg, 10, equals leg, which is 10, over, what's the connected part? X. I don't actually even need this. I would need this if I wanted you guys to find this leg, which eventually we will do those. So that's actually not even necessary for this problem. 14 times x is 14x. 10 times 10 is 100. Please divide 100 by 14. Make sure you simplify. And it gives the answer as a fraction form. Try to stay away from decimals as much as possible in this unit. So it's 50 over 7. We'll try one more, and then we can stop. We're going to come back to h and I later in the week. So for g, because we have square roots in the problem, it looks a little bit different, but it's completely doable. First off, is this altitude or leg? Altitude, right? The legs are not even labeled for now. So we have square root of 3 over x, and then equals x over square root of 6. Let's cross multiply. X times x is x squared. Square root of 3 times square root of 6 is square root of 18. The biggest perfect square for 18, that's 9 times 2. Square root of 9 is 3. And the answer would be 3 square root of 2. Because you can multiply square root of 3 and square root of 6 because they're both radicals. So root 3 times root 6.
Yeah, I know, but the x squared is still there.
No, well, x squared is right here. X squared equals the square root of 18. And now, you're right, we didn't finish. Take the square root of it. Oh, this is kind of funny. We'll have a double square root. You're right, Finn. I lost track of my x squared.